Hello, beautiful people, and welcome. In today's video, we are doing a few examples of factoring with difference of squares. Now, what that is a very special binomial where we have a squared term that is the first term and a squared term that is the second term. That, when factored, gives us a very special binomial multiplication. As always, disclaimer, if I make a mistake, I am human. Please let me know where the mistake occurs so that way we all can learn from my mistakes. Let's start with the very first one. So when you're writing these difference of squares, you're going to follow this pattern. You're going to want to write it in the form of a, and we're choosing to put that in a bubble, squared minus b squared. So if you can rewrite the first term as a square minus the second term that's also a square, then what you have is the difference of squares. So a plus b times a minus b. Now it's super duper important to note that one of these has an addition, one of these has a subtraction, so that's going to be your special binomial multiplication there. And then pay attention to what you originally have. Originally you should have a minus. For example, here's a minus, here's a minus, here's a minus. If you do not have a minus, then it is not the difference of squares. But if you do have a minus, then you can do difference of squares as long as you have the first and the second term both be squared. All right, let's go ahead and jump into example number 1. For x squared, can you rewrite it as something squared minus 25? Can you rewrite it as something squared? And in fact, we can. X squared is just x squared. But this time we're writing x in a bubble, then we have the squared on the outside. 25 is 5 times 5, which we can rewrite that as 5 squared. Because we can do this, then we're going to have a plus b times a minus b. Now, what is your a? What is your b? Your a's are your first term, so here's your a. And then your b's are your second terms here. So how will this look like in factored form? It will look like x plus 5 and x minus 5. Now this is your answer for the factors of x squared minus 25. Let's do that one more time. Again, we want to rewrite this as bubble squared minus bubble squared. So x squared, how do we rewrite that? We're going to rewrite that as x in parentheses squared. 36, how do we rewrite 36? Well, 6 times 6 is 36. I'm going to rewrite that as 6 squared. Here's my a, here's my b. So this is going to look like a plus b times a minus b. And that's our answer. Let's do one more. Again, let's actually not do it here. Let's see if we memorize the pattern. X squared is just x. 81 is 9 times 9. And then one of them is plus, one of them is minus. Here's our answer. Let's move on to example number 4. For example number 4, it looks like we have 64. We have two things. That's okay. You're going to treat them as two separate things in the beginning, and then you're going to treat 9 as a third thing, even though we still need two things. 64 is 1, 2, 3, 4, 5, 6. That is 8 times 8. So we have 8 squared. X we can rewrite as x squared, and 9 we can rewrite as 3 squared. Because we want the form of bubble squared minus bubble squared, this 3 is okay, but it's on its own. It's not being multiplied here by anything. Here we have 64 times x squared. So we need to combine this 8 and this x. So we have 8x. So what happens is this 8 comes over here, and this x is brought down here. So that's where their 8x comes from. And we have the square, just one square. So now we have our a and our b. So we have a, b. So a is 8x, b is 3, and one is a plus, one is a minus. So here is our difference of squares. Let's do another one. 144. Now that is something that you need to know. I believe we need to know all the way up to 15. So 144, it is 13 times 13, I think. So it is not. I believe it is 12 times 12. It is. So that means I have 12 times 12 here. That means I have 12 squared. And I have x squared, so that's x squared. Here I have 169, and 169 is the 13 times 13, so here's 13 squared. Again, we need to combine these into one bubble, so I have 12x squared. Here I still have 13 squared left over. Still have my minus. So what do we have? We have a plus b, a minus b. So here's our a, b, b. One's a plus, one's a minus. Now it doesn't matter which one's plus, which one's minus, since they are being multiplied and they're the same thing. Do one more 16. 16 is 4 times 4, so 4 squared. X is just x squared. And 9 we said was 3 squared. Let's do that in bubble form. Again, put these together, so I have 4x. This 3 is just by its lonesome. So again, I have a plus b, a minus b. So I have a, b, b. One's a plus, one's a minus. Do 3 more examples here. I'm going to shift this up. All right, what do we have here? We have 2x to the 4th power minus 32. Well, 2 is not a perfect square. I can't have, 1 times 1 is 1, 2 times 2 is 4, so there's no number multiplied twice by itself in order to get 2. So maybe I'm thinking there's a GCF. So let's see here. Can I factor out GCF from number 7? So if I try to factor out 2, I'm going to have x to the 4th left over and 32. 32 is even, so I'm thinking we can pull out a 2, which leaves me 16. So I'm doing a happy dance because 16 already is a perfect square. So I'm going to keep this 2. This is my GCF. And I'm going to make sure to include it in my final answer. Now here, I'm going to continue. I'm going to keep my bubbles. I'm going to continue with factoring, and I'm noticing that I have a perfect square. X to the 4th power is x squared, and 16 is 4 times 4, which is 4 squared. So that means I have a and b. So a is x squared, b is 4, one is plus, one is minus. So this here, including my GCF, is our final answer. Let's try it again here with 36. 36 is 6 times 6. I'm going to have 6 squared. Ooh, I'm thinking we can pull out a GCF on this one. Like, for example, 36 divided by 3 is 12. And 9 divided by 3 is 3. However, these are already perfect squares, so we can just factor it this way instead of pulling out a GCF. The reason we pulled out a GCF in question number 7 is because 2 and 32 were not perfect squares, and we wanted to force them to be perfect squares. So let's go ahead and continue this one. Z to the 6th power is z cubed squared. Minus 9 is 3 squared. Again, we want to put these together. So I have z cubed times 6 squared minus 3 squared. And again, we want our a plus b, a minus b. So I have 6z cubed as my a. I have my 3 as my b. One is plus, one is minus. Here is our answer. Try one more time here for example number 9. X to the 4th is x squared minus y to the 8th. And again, I'm thinking it needs to be squared. So y squared. So 2 times what is 8? 2 times 4 is 8. Remember, if an exponent is being raised to an exponent, then you multiply those exponents. So 4 times 2 is 8. So it means I have my a, which is x squared, and my b, which is y to the 4th, and one is being added, one is being subtracted. All right, beautiful people, thank you so much for watching this video, and I will see you in the next one. Bye!